Welcome students for this 16th lecture on equipment for precision planting. Well, before I go details into this, I think it is very imperative that I should talk about what precision planting is. Precision planting, you must have seen that so far we have been talking of application of more and more fertilizer and getting more and more yield over the years. And now a time has come that we are getting negative effect of those fertilizers which have been applied in several parts of the country and the world. And then we have started thinking as to what is to be done, what sort of fertilizer to be given, what amount of fertilizer to be given. Then we are also thinking, because the area has shrunk and we know that the population, I discussed in my previous lectures that the area has decreased and the population is exploding. We know that by 2050 the whole world will be some 9.1 billion people, and in that context it is very essential that we must look into all the resources that we have with respect to the infrastructure, with respect to crop production, with respect to the other inputs in crop production, because we want more and more yield to feed the population which is increasing. In that context, it is very important that we do think of each and every input that we have with us for crop production. It starts with the tillage energy itself. We are looking for equipment which should give us minimum passes of the equipment for getting the soil tilth, which is required for giving a proper environment to the seed, so that the seed will grow. After that, we are looking for a good quality seeding mechanism, seeding equipment by which we should be in a position to put only the exact amount or most optimum, you can say, amount of seed which should be put, so that it gets a better environment. And it is not that earlier we are thinking that okay, let us take to 120 kg or 130 kg per hectare of a seed rate. But then what is important is we must know what exactly is required. So we need to know what is the amount of seed. Similarly, then we will think of the machine energy, we will think of the fuel energy, we will think of completion of the operations in time, because then we need to take another crop, because the whole time is fixed of the year. Within that period, we have to take several operations to be completed, so that we get maximum output from the field, hence increasing the cropping intensity. So all these inputs need to be thought of in the precise manner and to be applied in a very precise way, and for that you need to get proper equipment. So we will just talk of the equipment for precision planting. We will talk of planting. You have learnt earlier that seeding and planting, slight difference is there, because when we are talking of planting, it could be that we are maintaining a seed to seed distance or a hill to hill distance. Sometimes we also talk of transplanting, that means planting has been done at one location of a certain size of the seedlings, and those seedlings are picked up and then planted in the real field, where they grow and actually come out as a big crop, and we get the yield out of that. So in that series, we will talk of precision planting. So let us look into this, what this precision planting equipment is. We will talk of one equipment at this point of time. Well, precision planting implies accurate spacing of seeds. Yes, accurate spacing of seeds, very important, or planting of vegetable crops, and creating an uniform germination environment for each seed. This is very important. This is what we mean by precision planting. Accurate placement of single seed in soil ensures saving of costly seeds. Sure, as I discussed to you. Reduce the problem of thinning and crop yield. Yes, it will, because if you have put lot of seeds, then a time may come when you will require to thin this, and such that there will be control on the weed growth, because those weeds are also going to compete for the nutrients with the crop plant as well. That is why we have to think of proper weeding operation as well. Therefore, this is very important. Among various precision methods, the pneumatic metering system are widely used for sowing seeds of various plants. Now, this is one. The pneumatic one is more precise among the other various types. In fact, I have also shown you in my field operation about the equipment. We will talk some more details of this, and it is very important from a designer's point of view. You will be all designers. At some point or the other, you would like to design a particular pneumatic equipment. You must know what is the type of equipment, what are the essential features which the particular equipment should have, and what are the important formulae, etc., which are required for that. So, let us go into the details of this equipment. Pneumatic multicrop planter. Yes, I have shown this thing in the field to you already, but then it is very relevant that I should show you here also as to what are the more details of that, of this particular equipment. Well, we will start with the last operation, that is the press wheel. The press wheel. See, this is the one which does the job after the seed has been put in the soil, a coverage has been given, and the pressing wheels, they are going, and then they will press it to certain extent we require, so that there is a proper mechanical impedance or a thrust, soil thrust, which the seed has to germinate. For that, so we need to have press wheels. Then the seed covering device, we go to the next one, which is seed covering device. Once the seed has been put, what is the covering device and how does it work? So, we have a covering device over here. Then marker wheel, this is another point which you must see, that this marker wheel marks that we do not leave any portion of the field while this operation is going on. It is very important from that point of view. So, this is an important item which should not be looked upon and which should not be just neglected. It is very important. Then seed metering unit. Well, this is the seed metering unit here, seed metering unit, how the seed is metered from its hopper where it is. Then the seed hopper, this is the seed hopper here. There are individual 4 hoppers, as you can see. There are individual 4 hoppers. Now, there is a this is a multi-crop, it is also a fertilizer unit as well. That is why the fertilizer hopper is also given over here. Now, in the fertilizer, these are the fertilizer tubes through which the actual fertilizer will go and go into the location at which it should be put while the seeding is being done on a particular location. I have discussed about this, you may recall that what should be the proper placement of the fertilizer with respect to the seed. So, you may recall that, and accordingly this fertilizer is being put when the seeds are being sown through this pneumatic planter. Now, the depth control. Yes, we need to maintain a depth control through this wheel. So, we have talked of this because it is very important that depth control should be there. And if you go back, we also discussed about the laser land leveler, where it is very important not only from the saving of water, but also from the point of view of saving of the unnecessary delay in movement of the vehicle or movement of the equipment when it is in the field. So, we would like to maintain the depth of operation. So, this unit is there, this is how we maintain it. Now, aspirator, there is a aspirator blower here. Now, this blower, if you see, I have shown you in the actual field condition, but see there are 4 tubes coming out, 1, 2, 3, 4, these 4 tubes are coming out, and this blower is operated by the PTO, power from the PTO. So, PTO is operating this blower, and from these tubes they are coming into the plates, actually seed metering unit. This is the seed metering here. Now, what is there in the seed metering unit? We will discuss this next, because once the seed is there in the seed hopper, it is open to atmosphere. This is one part of it. Now, when it goes to the soil, it is again in the atmosphere, but in between how do we precisely take from the hopper and then put it back into the into the soil. Now, between this what happens? Let us have a look at it. Well, for this pneumatic planter also it is essential to know what are its advantages. A lot of advantages are there. As I told that we are very much interested and concerned about keeping the seed at the right place in the soil and in the right amount and right spacing. So, because we are going to get higher yield if we maintain this environment of the seed. So, what are the advantages that we get out of this? Picking efficiency, you find that pick efficiency is 99 to 100%. It has to be, because the moment we talk of precision, we are talking of individual seeds, irrespective of whether the seed is of what size, shape and all that. What is the size of this? It doesn't bother about that. What is the shape of this seed and what is the size of the seed, etc. Okay. With clean and graded seeds, yes. Self-filling, this is important, that we should not have a missing. So, we will find that self-filling is also very high, you can see 99 to 100%. Irregular shaped, as I said earlier, that the size and no mechanical damage. This is important, because see, if I have put the seeds, many times we also take care of the germination point of view, viability, what is the level of viability of a particular seed. So, we take care of that, okay, germination percentage should be about 80% or 90% like this. Why do? Because there are chances that some of the seeds may be faulty or some of the seeds may get damaged when they are passing through the metering mechanism. So, particularly if you recall the metering mechanisms which are there when we have the fluted roller and other equipment, other types of devices, there are every chance that the upper portion of the seed may get damaged. There could be a superficial damage, there could be a yield critical damage, because the superficial damage may not lose yield, but a critical yield, critical damage which will be responsible for yield, and that will not happen in case of this pneumatic seed drill. This is beauty of that it will simply be taken from the hopper and it will be transported through air medium into the soil. Well, in this there are two types of devices which have been available in literature, and at this point I would also like to tell you that, see, as a designer you must think of a third type, or you must think of a mixed type, or you must think of something new, so that even you can think of a better mechanism, better device, a smaller device, a more efficient device than what it is. Remember that no system is perfect. We can always think of perfection, better and betterment of any system. So, while we tell you that what are there in the literature and what are being in vogue in the use, you must also think of something new, and for that what parameters, what attributes, what design aspects you must consider, we will discuss those things. So, let us have one unit which has air is supplied through a drum where air pressure of this is maintained. I have shown you the drum already from this, from the hopper. Now, you see that the air which is coming from the tubes, through the tubes which you have seen earlier, those tubes are entering into a drum. Now, air pressure of about 4.1 kPa is maintained, and air escapes through the holes in the seed pockets until a seed enters the pocket. Now, what happens? There are pockets in the seed plate itself. I will show you. So, what air is passing through that, and the air in the hopper is at atmospheric pressure, and here you are passing the air maintaining a pressure about 4.1 kPa. So, differential pressure holds each seed, because the moment there is a differential here, you are giving this much pressure 4.1 and the other side is atmospheric pressure. So, the differential pressure, the moment seed comes there, it will be held over there, and that goes on, because that will go along with this metering mechanism. At one point, if there are more seeds taken, then it will be brushed off and then single seed will fall. So, this is the system which is appropriate for some of the crops like corn, gram, beans, sorghum, could be other ones which are smaller and which are required. And seed disc with different size holes are used here. This is another beauty, that you can, as we discussed in the earlier slide, that you can have different sizes, different shapes, etc. So, this different sizes of holes, etc. are available in the disc. These are available, so they can be put. So, here is another aspect of design. You can think of a proper design of those seed pockets or those seeds sizes, depending upon which seed. If these are meant for a particular smaller seeds, if you want slightly bigger size seeds, if you want certain oval seeds or whatever, you can incorporate in the design and come out with a different design. So, this is the aspect of type 1. In type 2, a suction is used for picking the seeds. We would like to suck from in a drum where the seeds are rotating, a drum is rotating, and a suction is created, a vacuum is created in a drum, and the device, this is okay. Singular modular type metering devices are used in this type of planter. Now, what happens is, again, the way we have maintained there here, and a blower is used to create a suction pressure of this. This suction pressure is here, because you will see that its suction is created out of the device in the drum itself. So, this suction pressure and blower inlet chamber, which is connected to the vacuum disc of the planter unit. Now, this is connected to the vacuum disc of the planter unit. The seed metering disc has holes on its periphery. It is important that the seed metering disc has holes in its periphery and the suction is created. So, they will be all held on the periphery of the seed plate. Air sucked from the holes of the metering disc, thus forcing the seed against the holes on the seed. As I said that yes, there are periphery holes and there will be where suction is being created. So, they will be just moving on the periphery and they will be carried on the periphery. And when the pocket passes the baffle that cuts the vacuum from the disc near the openers. So, there is location at the near openers, there is a baffle there. So, seeds are removed, are moved up and released when the pocket pass a baffle. Now, we will see this what it is there. So, we have talked of two aspects, one where their air is blown and then there are disc and we are maintaining a pressure difference on the seed of atmospheric pressure on one side and the say 4.1 kilopascal on the other side, and there we are maintaining this one type of metering mechanism. And when the seed is when the seed is moving on the seed plate, it is brushed off if there are more number of seeds, and only single seed is then dropped in the earlier case. In the second case, we are maintaining a vacuum, as I said here, and then in the vacuum in the periphery of the disc, the seeds are there held, and the moment there is a baffle which cuts off this the vacuum, immediately the seed will be released at the end of the opener, at the location where it is supposed to go. Yes. Now, this will clarify to you as to what exactly I meant over there. See, this is the seed metering unit. See, this is the seed metering unit here. The seed box is here. This is seed metering plate, and more details are given here. There is a suction baffle. Now, this suction baffle at 330. You see here the two baffles, suction pressure baffles 330 degree, maintaining 330 degree. You can see that they are maintaining this, and there is a positive pressure baffle of 30. Now, this is through connecting to outside through a long cut. Now, this is the long cut that is there on the plates. So, what will happen is the moment the seeds come around this point here, they will be released, because this will is related to positive pressure or to the atmosphere. So, the moment this comes here, or the seeds will come over there, this portion will be over the atmosphere, and hence the seed will fall, and the seed will go to the soil. This will go to the soil. So, this is as simple as that, but you need to understand, if you want to design a new device, you can think of what exactly is the pressure. In the literature, we have talked of that the pressure of 4 should be maintained. Somebody says that 3 to 5 kilopascal you should maintain, and things like that. But for different types of seeds, for different shapes of seeds, what are these values, how they should be actual values to be maintained in a particular device, it is a concern for the designer. So, if we consider that this device, which is already available, this is the method by which the whole operation takes place. Design of seed metering devices. Well, here it is important to the extent of understanding certain things, because how will you say that the seed metering device is designed, or how will you assume a seed metering device? See, angle of repose. What is this? The angle of repose had to be with respect to the seed. The angle of repose has to be with respect to seed. Now, if you consider this is the, say, if I consider like this, H, and so you see this cone height, this is the height of the cone, this is this. So, when the seeds are actually, this is what we are trying to create, that what is this, the angle beta, this beta angle is given as this, very simple, you from simple geometry you can see this, that how we can get this. Now, about the seeds, sometimes when we are talking of the seed metering devices, we are definitely concerned about what is the common parameter of a particular seed. A seed has a length, has a breadth, has a thickness. So, what is the common parameter which can be thought of, can be taken for the design? And there we find that the geometric mean of this of the seed, or geometric mean of seed diameter. Now, this is very simple when we are talking of the length, height and thickness of the seed. So, assuming this, we know that the geometric mean diameter of the seed is can be given as this. These are important actually, because when you decide the factors, when you decide the design, you must have an idea about the seed metering device. What is the type of seed, how do we take the parameter of the seed with us in the design. And the important parameters are this angle of repose of the seed mass when it is formed, and the seed size. So, one parameter we will take, and instead of L, length, thickness and the height, etc., we would like to take a common parameter, which is geometric mean diameter of the seed. Well, revolutions per minute. Now, how will you, there are certain things which you must understand. Actually, revolutions per minute of the ground wheel. Now, you should understand that the tractor is, when moving, the ground wheel is the ground wheel of the tractor, but then we have also the ground wheel from where we have taken the power. So, it is important that we assume that there is no skid of the ground wheel. So, we are assuming that the speed at which the tractor is moving, same speed we will take for the metering mechanism we are talking. So, revolution So, here N is the revolutions per minute of the ground wheel of the planter in RPM, diameter of the ground wheel d is diameter. So, from simple pi d n you will be in a position to find out this, where V is the forward speed of the tractor, V is the forward speed of the tractor. Now, peripheral speed of the desk, number of seeds dropped by metering mechanism per second. It is very simple. Once you know that this pi d n is the distance covered and S is the seed spacing in rows, by dividing you can simply get what are the number of seeds dropped per second. Once you know the number of seeds per day, the distance between two consecutive holes on the plate is important. And that how do you get that? Because you know that pi d, d is the pitch circle diameter of the seed plate, then n is the number of seed holes on the seed metering device. So, once you know pi d by n will simply give you the distance between the consecutive one, as which we have shown over here. Therefore, what is, we have got two things here, the number of seeds dropped per second, and here we have got the distance. So, if you multiply this, you get what is called the peripheral velocity of the seed metering plate, and this is what it is. So, it is in a very simple way I have tried to explain to you how you should consider the when you design a seed metering device, and maybe we will have certain numerical problems on this in the later course of deliberations on this, so that it will give you more clarity on this aspect. Well, seed vacuum, actually I told you that there are seed vacuum values which has already been given in literature, and I also pointed to you in my earlier slide. But then some researchers have, as I told you, that as a researcher, as a designer, you must think of finding out values, accurate values for different sizes of seeds and implements and machines that you want to design. So, one gentleman whose work we are quoting here, Zhao et al., they have found out what should be the suction chamber degree of vacuum in the suction chamber in a particular, for a particular seed size or a particular condition of the environment of the seed, soil, etc. Now, if you go to the details of this particular reference, I have particularly given this, so that it's about 22 years back or so. But then if you go, there is a way by which they have calculated. See, suction reliability coefficient they have found out varies between this to this on certain aspects, certain parameters. External condition, they have also decided what is the external condition of the seed in which this job is done. The distance from seed center of gravity to the discharge plate, that means seed center of gravity of the seed to the location where it is dropped, and seed gravity, one seed gravity, as if when one seed is falling, what is that. So, the values of K1, K2, Cg. Now, this is the linear velocity of the seed suction opening of the discharge plate. This is important because we have discussed earlier what is the linear velocity in the previous slide. So, that is important, and of course, the diameter of the seed suction opening onto the discharge plate. Now, another aspect which they have talked of is lambda, comprehensive coefficient of the seed frictional resistance. Now, this depends on 6 to 10 times tan alpha, which is the angle of repose. So, I mean it's one must appreciate their effort here, because they have found out as to what should be the degree of vacuum that should be considered, a way of doing. And in fact, if you read the details of that, you will find that they have found out for a particular seed and for all these conditions which they have designed, maybe more details you can find out in this particular reference itself, and they have found that a value is about 5.2 kilopascal or so. So, you may go to that and have an idea. This will also give you an encouragement to think of why 5.2, can we think of this K1, on what basis these values have been thought of, on what value this has been thought of. You can think of this design, and contribute yourself as a designer, which is the requirement today. We must question what is a particular person has done. Not that we should say wrong, but we should see what new, what best can be done. Details of seed plates used for different crops in pneumatic planters. Well, this is an information which we have taken from literature, and we would like to give you that some of the important things: recommended seed spacing for soybean, sorghum, pigeon pea, mustard, okra, maize, groundnut, cotton. These recommended seed spacings we have given. Number of holes on the plates which are generally there we have given. Seed hole diameter also is given. Air suction pressure is also given. So, these are information which are already available in literature, which we have given to you, but then as I discussed, as a designer you must look into the seed metering device, the pressure to be maintained, the size of the wheels, the size of the pressing wheels, then the placement of the marker, then the side of the tube, then the design of the plate, etc. You must think and then come to the details of a particular design. This will give you an input for your design when you are going ahead.